the geography department. Okay, great. So I'm Tianjie Feng, a faculty member at the geography department. I'm pretty excited to tell you a little bit more about this brand new cross-disciplinary program, XDP in Geospatial Intelligence. So this is brand new and is co-hosted by Geography and Computing. It's an interdisciplinary program, so later you will see that the training that we're providing is not just geography, not just computing, but there is an integral part that's very much needed in the current workforce. Okay, and I'm also very excited because if you follow the news, there's this new agency, the National Space Agency of Singapore, where geospatial intelligence actually plays a crucial part of it. And also, if you follow some news on the AI world, where there was actually a claim that the spatial is the new need, which is the most critical things in human life. Okay, so I guess in the next 30 minutes or so, perhaps no more than 40 minutes, I'll tell you a little bit about what the geospatial intelligence, what the geospatial intelligence is about, and tells you a little bit about what the industry player has feedback to us and what's the need of the industry. And then eventually tells you a little bit about what the student will learn and eventually get out of this program. Oops. All right. So perhaps let's start with what is geospatial intelligence. So, so basically, if you imagine that in your everyday life, you might be checking on a bus app to look at when the bus is arriving. Or if you're driving, you might be looking at Google Map to look at where the traffic congestion is. So based on this kind of intelligence, you will be able to say, okay, I'm going to wait in my house for a few minutes before I go to the bus stop, or I may be taking an alternative route to go from my home to my workplace so that I would not be spending too much time on the road. Okay, so these are some of the daily kind of the daily intelligence that we use to save our travel time. So you're looking at a kind of common application of geospatial intelligence for daily commute. Okay, so these are at the application level, but then if we were to look at, for example, how does the app know when the bus is coming and why is it? Of course, we all experience that the app may not make the prediction correctly sometimes. But if you were to look at the transportation information on Google Map, they are generally very accurate. Okay, so the question becomes, how does Google be able to actually make that kind of prediction to the level that's actually applicable to the daily commute? Okay, so we're not looking at just simply looking at map, but actually looking at this thing called the science of where. So how do you make location intelligence that would actually help our daily life? So in a way, in this particular program, we're trying to combine geography, combine computer science and data science, as well as the technology. For example, we're using satellites or we're using drones to collect data, and we're also using data analytics. So a lot of it today is related to different tools in artificial intelligence. And also this is where the whole of Singapore is pushing forward into. Okay, so we're looking at data, big data analytics to address, for example, earlier we're talking about how we may be able to make prediction about where the traffic congestions are. But then you could also look at application that goes beyond just transportation, but also looking at precipitation or rainfall. So if you go to the NEA website, you will be looking at well, the next 24 hours, whether or not we'll have precipitation at certain locations. Okay, so these are the things that are all related to geospatial intelligence. And the underlying principle is to look at the science of where. So how do you make predictions at certain location that would benefit our everyday life? Okay. So that's more of the broader kind of context for why we want to have geospatial intelligence as a curriculum. So with this slide, I suppose it's clearer if you were to look at the sample or the image on the right side. So this is clearly showing the connection with the soon-to-be established the space agency. So what you see on the top are basically satellite collecting information about the urban environment. In the middle, you will have this thing called a LiDAR scanner. So these are the type of technology that's being used in autonomous vehicles as well as surveying the urban landscape. So we could use this kind of data and couple with the big data analytics, such as the Geo AI processing in the middle. So, so these are technology, data collection and data processing. But in terms of real life application, perhaps NEA or URA are interested in where the green spaces are in the city. And we use it to look at issues related to, for example, urban resilience. We're looking at urban heat islands and how do we plant more tree that would connect to human life? Where do people want to spend their time to perhaps relax a little bit? Okay, so so obviously, if you were to look at the example shown in the figure, we're not only talking about technology, we're not only talking about computer science, but we're also talking about how the urban residents will benefit from the technological development. And obviously, these are all requires a cross-disciplinary training. That's why we created this program. So if you were to look at the XDP as a program, we're providing 1 degree. And based on the example that I just mentioned briefly for the past 3, 4 minutes, this 1 degree will actually give you an endless career path. So for example, Save the Planet, you might be looking at application related to climate change. And under climate change, you will be looking at sustainable development, which is very, very important for Singapore because of the land scarcity. You may be looking at urban heat island and how to remediate it. And you may be looking at sea level rise and how do we prevent us from being damaged by the sea level rise. And we could be looking at smart cities. So there were examples about where to set up the solar panel. So that would help us to reduce the energy footprints and the carbon footprints, things like that. And protection and serve. Personally, I have collaborated with police force and a little bit on the MINDEF side. So you may be looking at, for example, MINDEF provide humanitarian aid, and they really need to have locational intelligence to look at where do they fly the plane, where do they drop the things, and police force obviously is for public safety. And of course, eventually, you may be looking at career path into power business. So you may be looking at where the Amazons or a big corporate wants to set up their warehouse. That will be the bigger business kind of applications. The more recent one, if you actually follow the global economy, looking at this kind of semiconductor chips. So when the bigger company wants to set up the factories, for example, in Arizona, in Nagoya, also in Germany somewhere, why do they set up the business at certain locations? So these all require certain kind of locational business and is mission critical because it's really about whether or not the company is generating revenue. And all of this will require certain aspects of geospatial intelligence. Whoops, sorry. So, so from the student's point of view, you might be wondering, so exactly what do I learn? What do I get out of it? So this slide is just to provide an overview as an example. So on the upper left side, you may be looking at data collection. So if you're the person who likes to have a balanced kind of learning experience, you don't want to sit in the computer lab 100% of the time, but you also want to spend a little bit of time outside to look at the real world and understand how the data is being collected. There will be courses related to primary data collection. So you go into the field to use whatever data collection tool to collect data. And on the upper right side, and of course, the data will have to be processed to turn data into information. And eventually the information and informed decision making, and that's where the intelligence is coming from. Okay. So the training side would also involve the basic that enables you to do this. Okay, so that would include some computing, foundation computing training on Python, AI, and machine learnings. But of course, we'll be focusing on these thriving fields in geospatial. So, so on the lower left side, this particular curriculum would also focus on or emphasize on the impact. So you're not just a data scientist who are sitting there to collect data and they do the data wrangling, but you wanted to create some kind of impact. Okay, so you're not generating a map, but also you use the data to fight certain things. So certain issues such as wildfire, plant disaster relief, as I mentioned earlier, where I think the MINDEF is doing that as well, and also design smarter cities. So, so that's where you see your training would actually create impact in the real world. And perhaps you could create what is called the digital twins. So these are just to put it in the context of Singapore, you might be create a virtual city in a computer, which is the digital twins. So you will create that virtual replica to test solution before building them. Okay. So it's just like you go to the department store and you might want to put on a outfit to see if it actually works. You can do that in computer nowadays. So virtual figure, and you put in the virtual clothes to see how it works. And if you like it, you go to the store to buy it. So digital twins will be the similar concept, but work at the city level. All right. So of course that's just to provide a little bit of background on what exactly is geospatial intelligence and where it is being used. Here, I just want to show a field example and just to highlight that the big corporates such as Google are very much into geospatial intelligence. Okay, so if you look at the slide title, so the impact that it's creating is to fight fuel emissions. And the tool that's being used is the artificial intelligence as well as the information from Google Map. Okay. So the context of it was that we all know that we want to reduce fuel emissions, but what would be something that can be easily done with the current infrastructure? So we don't invest on new infrastructure, but we want to reduce fuel emissions. So let me stop the animation right here. So the idea is that if we will be able to leverage the spatial data, if you look at the image on the right, if we can leverage where are the traffic congestions and then knowing exactly, if you look at what the AI does, so if we know which car is waiting for too many seconds, that means they're waiting for too long, and at which particular intersection and at what time. So you're looking at geospatial, you're looking at temporal, and you're looking at a problem which is waiting for too long. Okay. So Google actually, this was a few years ago, they actually has a research project looking at this and see whether or not they can use the geospatial intelligence to dynamically change the length of the green lights and the red light. So So the end goal is to reduce the idle time, which means that it would also reduce the fuel emission. Okay. So if you're interested in this type of work, the link is at the bottom of the slide, which you can read up a little bit more. Okay. So hopefully that provides one example about a big corporate. They're also into geospatial intelligence. Is actually a very big field. Okay. So the other project that Google was working on, and this is inspired by post-COVID. Okay. So of course, we still have a good memory of what the COVID was like. It's not very convenient during the lockdown period. So there's this big problem of how do we design the urban space for post-COVID, okay, so that people can still live a healthy life. So Google actually has another project related to geospatial intelligence and looking at redesigning the cities for the people and not just for the car. And you could tell that in the middle, we're looking at an aerial photo, and there are AI models that help us to identify where the greeneries are. So this, of course, is a map, but you could also look at the distribution of the greenery. And they also have information about people, where people walks and cycles, so they can correlate these type of thing also associated with, for example, the solar potential. So eventually they will have some idea about where the location they should plant trees, and that will maximize the benefit of the city residents. So this is where you're not talking about park, but perhaps talking about community gardens, community parks, and other rooftop gardens and things like that. Okay, all right. So this is another example where the Google is getting into, for example, daily life, and especially looking at geospatial intelligence and its application. So I suppose we have a lot more examples that we can talk about, but those two examples from Google should give you some flavor of why geospatial intelligence is important. And with the geospatial intelligence XDP, or we acronym as GIX, so there are other applications which, if you're interested, you could click on the link to look at other applications related to disaster management, urban mobility, health promotions, and also autonomous cars and electric vehicles. So those examples from Google is complemented with another company. These are also very big. Esri, this company actually has a big Singapore presence. They're actually a subsidiary of the Boston Singapore, which is a Singapore stock market listed company. So what they're talking about in terms of GIX or geospatial intelligence is the underlying technology, which is called a geospatial artificial intelligence or geospatial AI, which help us to pretty much extract information from satellite imageries or air photos, which is kind of related to this newly established National Space Agency of Singapore. Okay, so in this case, you're looking at extraction of where the buildings are. Okay. And the GX will actually, when you look at AI and GS application, is pretty much looking at geospatial intelligence, which you can pull everything together in a digital twin kind of environment that will help you to automate analytic workflow or to look at elevated prediction analytics, as well as optimizing the operational performance. So these are all quite necessary and quite needed by the government agencies and several local companies that we interviewed a few months ago. So, so other than looking at the interest from the big corporate into geospatial intelligence and what's the impact that it might create for our daily life. I just want to draw your attention to two publications, and one is from SLA and MPA. They worked on this second version of the Singapore Geospatial Master Plan, which is from 2024, a little bit more than 1 year now, and basically a 10-year master plan. Okay, so the document is fully online, but relevant to this talk or this session is if you were to look at the highlight, they're basically call for increasing geospatial adoption, meaning that Singapore needs these kind of talents. And it's not just about quantity, but we're also looking at the quality, so deepening the core capability and position Singapore as the thought leader on the global stage. So essentially, you're looking at leading agency on GIX in Singapore that is calling for the need of this kind of education. And still fairly recent, there is this number about US dollars 681 billion, estimated the industry about this size, and it will grow to about 1.5 trillion in now about 4 years' time. Okay, so we're basically looking at a young and thriving industry, a field which would requires a lot of talent in this particular field. So this is fairly new. I think it was just released a while ago. So the National Space Agency of Singapore. So I wouldn't bother you to look at all the detail, but one of the key point was this is definitely a growing industry and growing field, and the prediction is about 1.8 trillion 5 years down the road. Earlier, in the previous slide, it was about 1.44 in 2030. And of course, this NSAS would have incorporated a lot of things. And geospatial intelligence definitely will contribute to a major part of it. So I just want to highlight three quotes right here. So there's this capacity building to provide satellite-based services for Singapore's national and regional need. And this would include geospatial data and analytics. And for government and business to consume decision-ready intelligence, it means that we would need to provide the talents to provide this kind of service. And the last one is quite important. Of course, if you look at the space industry, it would include those things related to engineering, about designing the satellites, shooting up the satellites, and so on and so forth. But one of the things that the geospatial intelligence will contribute is about this meaningful participation in space, which is about satellite data analytics, AI applications, and the use of space technology to address real-world challenges. Okay. So things that are relevant to Singapore could be just urban flooding, sea level rise, urban heat islands, and some other energy-related issues. So this is the slide talking about we did go to the industry and the government agency to solicit their feedback. And so rest assured that the curriculum design is actually taking their feedback. So that means it's going to be relevant to the workforce. So Esri is the company that I talked about earlier. So they commented that from the geospatial industries, employers are or expect to offer position to people with geospatial understanding. So this is more on the geospatial part and analytic skill, which is a combination of geospatial and computational and data science type of techniques. On the lower left corner, they also comment that an integrated training, so that will focus on synergistic approach is really, really important. And these training equip the students with the practical skills necessary to enter the geospatial industry, which is really young and thriving. Okay. So on the right side is more coming from the government's angle. So they see the current plan, the current curriculum, which is quite relevant to some of their core tasks. our current curriculum would have machine learning and artificial intelligence knowledge and skills in geospatial application. And this would definitely enhance employability. So this is coming from SLA. And MPA, which is, I kind of jokingly said that they're the Changi Airport, but for cargo containers. So they actually manage a lot of ships that's traveling through Malacca Straits. So they see that the training that we provide will be essential to meeting the evolving needs. So we're not only looking at the training for the next 2, 3 years, but much longer than that. Okay. And the evolving needs of the maritime industry and the potential for maritime geospatial application is high. So you're rest assured there will be quite a large demand for this kind of training. So with this kind of voices from the industry and the government, perhaps I just quickly summarize that yes, we do have data, and the data is considered as the new oil. This has been around for a while, but data is not enough. We need to have data practice. We need to know how to analyze it. We need to be able to connect with the problems that we have and not just looking at data analysis, but take actions. Okay. So it could be applied to technical business fields, such as location analytics to retails and logistics. It could be government, as you can see from the previous slide. It could also be health and environmental related. Okay, so it could be things related to distance tracking and climate resilience. Okay. All right, so high demand is the point that I mentioned earlier. These are from the voices from the industry and the government. All right, so now this will be the last part, I think. So just a high level view of what kind of courses that you will be getting. Okay, so for a XDP program is main difference between a major and a second major or a major to minor is really the middle part, which is the integrative training. Okay, but to have a solid foundation, we still have training in respective field, which is coming from geography. So we're providing core training in Geographic Information System or GIS. We talk about the real world problems in our world. And we also hone the geospatial thinking. And this is something that the industry actually feedback and say that they really need people who have very good geospatial thinking capability. But if you were to be just in traditional geography, that's not going to cut it. So you need to have foundational training in computing that enable you to run the advanced analysis. So there's the computing training, fundamental programming, advanced computing, as well as data science training. And then when these two merge or converge into the middle, we're looking at how these two sets of skills and and knowledge will be able to address certain kind of real world problems, as I mentioned in some of the previous slides. Okay, so this could be geo AI driven. It could be something related to problems that are crucial for the Singapore to address. And sometimes they will realize it's not just Singapore because we're just a tiny red dots. And sometimes there are problems related to other countries in ASEAN that the Singapore would also have to tend to. Okay, so it's not just Singapore, but it's neighboring and sometimes a global kind of issues that we're looking at. So again, this is just a high-level overview about the curriculum. So you will see roughly about the same number of courses from geography. So 9 courses, and computing is actually 8+2. The +2 is actually the prerequisite for some of the computing courses. And we have 5 courses on integrated problem solving. The rest would be the general education requirement that's pretty standard for any CHS or other NUS curriculum. And then we leave 8 courses for students to pick whatever they're interested in or whatever you're interested in. Okay. And it can also be used if you still want to take another minors or things like that. So the different options that you could use the UE or unrestricted elective to satisfy the requirement. So just go a little bit into the general topic about what exactly will you learn. Okay, so this is a 4-year direct honor for Bachelor of Science XDP. Okay, so these green boxes represents the knowledge or the skill that you will learn from geography side. Okay, so mainly about spatial thinking, geospatial data acquisition, so it will be something about the geospatial intelligence for everyday life. It will be things on the geographic information system that will be intro to GIS. We're not only looking at 2-dimensional space, we're looking at 3-dimensional, such as building and underground spaces, which is a huge topic in Singapore nowadays. Um, and then we have remote sensing. This connects to the space agency where we're looking at how to analyze the satellite imageries. And remote sensing for environment or RS for environment, these are things that ties to real world problems and how do you use satellite images to address those problems and eventually spatial decision making. Oops. So the computing side, so these are represented by this kind of pink boxes. So there are foundational computing skills such as programming, AI machine learning, and data structures and algorithm. And as well as if you look at geospatial intelligence, is sometimes it's not just about hard science, but also it has a huge business application. So we do have a little bit training on the business analytics. And eventually, there will be data science and social media computing, those type of things, which allows you to leverage spatial big data for decision making. So these 2 strings of core training will converge into the integrated problem solving. So these are usually courses at year 3 and year 4 because you do need the foundation from geography and computing from year 1 and year 2. So these would be things related to geospatial, artificial intelligence. So the geospatial comes from geography and AI comes from computing, and now they merge. And you look at the geospatial applications for addressing certain issues. At the bottom, we also have computational social science, and this also make this GX program super unique in the sense that we're really focusing on how these technology would basically inform decision making related to human life. So there's this human dimension which relies heavily on the social science perspective, but we kind of mix it with the computational approach. So that would also address a lot of pressing issues, not just climate change, but perhaps a little bit far-fetched at this moment. But if you look at the pressing issues in Singapore, there's this aging society that we're going to have to look at. Okay, so computational social science, it would actually help us to address a problem with a human dimension and human perspective. And this program is heavily geared toward workplace ready. So it does have industrial attachments or a capstone. And roughly speaking, industrial attachment is more geared toward getting a job after you finished. Capstone may be geared more toward if you want to go for a research track, going into the master and eventually PhD. Okay. But in any way, it provides the flexibility for you to plan out your career. So at the end of the day, when you graduate, roughly what you are looking at is you will be able to master the science of where. So you combine geography, computer science, and also the design capability to solve world's toughest puzzles. Okay, so address real problems. And you're not just restricted to data, but you're also using your data analytics to connect with real world problem, and that means impact. So you don't just analyze the problem, you actually provide solution, a reasonable one, a rational one to figure out how to fix the problems and also turn satellite image and big data into real world actionable plans. So the emphasis on for example, the internships and the capstone basically allows you to have a portfolio on top of a degree. Okay. So of course, we know the importance of getting a job. So with those internship opportunities, you'll be able to build your portfolio and hands-on skill and also demonstrate to your employer what capability that you have and eventually get a job, a good job quite more easily. So perhaps just a little bit add on where when we set up this new curriculum, and by the way, this new curriculum this August will be the first batch, so it's completely brand new, and that's why we're so excited. And when we're setting up this curriculum, we actually kind of triangulate with the curriculum with the competency framework from IMDA. Okay, so this table actually shows roughly about the roles and the job scope. It will be related to analysis, interpret, apply, and support development and maintain and integrate and communicate. Okay, so it actually has quite a nice mapping into the competency framework used by the Singapore government as well. Okay. So over time, over the past month, sometimes we were asked about the entry requirement. So right now we just say that we will follow the general requirements of the CHS, and there's no specific subject prerequisites. And we'll be assessing the applicants holistically with the emphasis on the interest, aptitudes, and readiness for a cross-disciplinary learning. Okay. All right. So that's all I have. I guess the rest of time will be for Q&A. So ready to map your future? So if you want to have more information, our official website is on chs.nus.edu.sg, programs and GI. And there is more information on the GitHub website called the GIX-Academy. All right, that's all I have to say. And any questions?